The standard normal distribution has a couple of properties. Just like normally distributed variables, the probability that z is greater than 1.26, that's shown on the left here, is equal to, because of the symmetry of these normally distributed variables, that's equal to 1 minus the probability that z is less than 1.26. This, incidentally, is phi of 1.26, and you can look that up in table 3, and that's how you can calculate probabilities of something greater than, of a z-value greater than a certain number. Also, the probability that z is going to be greater than a negative number, so note that negative sign right there, is equal to, it's the same because of the symmetry, that's just equal to the probability that z is less than positive 1.37, and that is, again, phi of 1.37 that you can look up in the table. This last one is used quite a bit, the probability that z lies between two values. You can subtract the probability that z is less than negative 1.25 from the cumulative probability that z is less than 0.37 minus the cumulative probability that z is less than negative 1.25. And so you could look these up in the table and you could do this math. So let's go through an example that relates to this. What is the probability that a result will be between 40.1 and 40.3? And before we do that, I have a question for you. The probability that x is between 40.1 and 40.3, we can convert that to z-values. 40.1 minus 40 over 0.3, we can convert that to a z-value of 0.33. We can convert 40.3 to a z-value of 1. So the answer to our question would be the probability that z lies between 0.33 and 1. And we could do the cumulative up to 1 minus phi of 0.33. And when we look those up in the table, we get about 0.841 minus 0.629, and that's 0.212. In summary, with today's computing tools, for example Excel, it is oftentimes unnecessary to convert random variables to standard normal variables. Unfortunately, your textbook doesn't really emphasize computing tools too much, like Excel, and it sort of implies that the only way of performing these calculations is through standardization. But that's not true, and there's lots of formulas to do this. In a follow-up screencast, I'll show you how you can do a lot of these different things in Excel. But for now, Excel's norm.dist function outputs capital F of x for any normally distributed variable, and Excel's norm.s.dist function outputs phi of z. And you can experiment around with the norm.s.dist function in Excel if you'd like. Nevertheless, it is important to understand how to standardize normal random variables and to use tables in the appendix. Hopefully you enjoyed this screencast on standardizing and z-values. Thanks for watching.